I will try to go as quickly as possible to just be on time. I'm presenting mainly major part done by my colleagues at the University of Osnabrück, Stefan Schneider and Benjamin Angler. And they give some idea and some aspects about what we call model construction in general intelligence, and give some experiments, cognitive science protocols and experiments to support or underpin these aspects of construction. So first of all, the motivation or the goal behind this is to shift the perspective from just searching to construction, which we are not alone in this direction, especially in the AGI field. So the perspective is shifted because actually as humans, in finding a solution to a given problem, we don't search exhaustively all possibilities, but we are selective in some way. So we favor the idea of constructing instead of exhaustive search. The example, as a quick example given by Mar, also these two sentences, if you read, the fly buzzed irritatingly on the window pane, and John picked up the newspaper. So the claim is, if you read these two sentences in conjunction, you might imagine or perceive a kind of insect damaging scenario. But on the other hand, if you just read the second sentence alone, one probably would think about John just sitting down and reading the newspaper. So actually we are selective in a sense. We are ready to be oriented. The problem constructs itself from according to the situation. Of course, this was proposed already by Neumann and Simon, who proposed that heuristic search is a cornerstone of AI, and that humans, while solving their problems, explore many paths in this solution. So the original motivation behind the word searching was not exhaustive searching, but was the exploration of several ideas while one is thinking about solution for a given problem. Because the systematic enumeration of all possibilities has at least two disadvantages. One of them, of course, is the computational interactability, and the other one is that it overstretches the cognitive metaphor of searching itself. They also proposed some kind of intelligence without much search by reusing of knowledge, selecting appropriate representations, making non-local use of information and stuff like that. So, still, till the moment, and despite these ambitious big projects in AI are still lacking general intelligence. So if we take the most famous or the most big AI projects like Deep Blue and Watson, they are claimed, at least by many scientists, not to be generally intelligent. Searle, for example, indicates that Watson does not know that it won. And also I quote this from a recent paper by John Licato and Selma, that they are just considered an intelligent simpliciter. However, they certainly are not general intelligent. And moreover, their vast knowledge bases are not compatible. Just imagine the mix of the rules. If Deep Blue wants to compete in Jeopardy and Watson tries to play a game of chess, this is impossible, almost impossible. So now, before giving this aspects of construction in the paper, I present the experiments, as I said, done mainly by my colleagues. So in the first experiment, human participants are given some description. Imagine a square with each vertical line divided into 3 equal parts. Connect the resulting division marks by 2 horizontal lines such that the square is divided into 3 identical rectangles. Add the 2 diagonals to the square. And now comes the question, how many triangles does the pattern contain? So I will not go into details about the experiment, but jump to the conclusions, because you are asked to mentally construct that according to the given description. So probably you might think about something like that mentally, and then connect the diagonals, and then you have to find the triangles that exist. Of course, the experiment is not concerned with the number of triangles, but how the participants construct them. And For example, you find a rectangle like this, one in the corner, a small one. By symmetry, you know that there are 4 triangles, something like that. So the main idea about this experiment is that we support the aspect that task is what guides the construction. So again, it's not assertion all possible connecting lines and intersecting points in the given mentally created image or so. That's one of the aspects, or some of the aspects for the first experiment. And at least the report indicates that the figure, as we know, is mentally constructed, and all components can exist, but some need to be kept in focus while thinking about particular triangle or another. In the other experiment, the participants were tested to complete a construction by just giving some kind of new or basic inception. I call it inception. It's the initial information or the instantiating information. So they are giving this sequence A, B, C, D, B, A, B, B. So, and they are asked to continue the given initial sequence, and all of them continued it by appending BC and BD. But after that, some major continuation aspects result. And after continuation aspects results, the participants have been asked to continue. And here is the point. When they come to a point where the original aspect of continuation fails, so at the beginning they thought that it's just a linear continuation of the 2-digit sequence, and then they don't know what to do after BD. Some people choose to skip C and start with DA, DB, DC. Others continue without taking care of a problem here that we don't have something like AA, AB, and so on. So this results in major continuation aspects, and each time a continuation fails to continue or to proceed, the participant tries to reconstruct the idea and start from again. So we have some, in the experiments, some major aspects of continuation, and these are the results according to the experiment. At least we know that focusing on one aspect, for example, a position expansion of any of these characters or letters, can bring up a metaphorical structure like a pyramid. So in the beginning they thought it's linear, and then they thought in the form of splitting or pyramid, another metaphor that modifies the earlier structure, which was originally the linear succession of letters, and it also can guide in constructing further details, which is fill center symbols or other symbols after that. So now the conclusion according to these experiments gives us some aspects of constructions summarized in these slides. So humans usually construct situation or problem situations consisting of only few elements, and this situation gives an immediate directive of what could be done next. And in this, what we call model construction, the directing structures is what guides the construction after that, and they are instantiated, and the instantiation continues according to a certain initial directive, and this direction, this directive either succeed or fail. The result of the attempt to realize the initial directive is a model, and then the construct till the point where the directing structure fails. Otherwise, try to reconstruct and use another directive. And this is my last slide. Let's say the take-home message of the aspects of construction. So we as humans are selective in our construction, way of constructing solution to the problems, way of constructing aspects of conception, our conceptualization or creating concepts. We actively attempt to assemble an intended structure by starting with a prototypical idea and make up a representation of the relevant parts to instantiate this idea. The whole conception or solution of the problem is in the background of one's orientation, and this brings things together. And if it succeeds, you continue. If it doesn't, then you retrace back and try to reconstruct according to a new directive. Yeah, that's all, and thank you.
We saved a bit time. Are there
That's
any
my
questions?
intention.
Yeah. Please come.
Should I go back to some slide or?
Second, I have just a small question. I want to know the conclusion of your paper or the produce, what kind of impact on AI job? Just because I personally want to know, yes, I can acknowledge that model construction matters much in general intelligence, but you say that we need to have a prototype first, then it can be modified. So the following question is, for AI engineers, we have two ways to do that. The first is to immediately fix the patterns or the construction, the models into the system. Then another is just get the system to have some learning capacity, and they will learn to have those models through experience. So what's your suggestion? How to do it in AI?
That's a good question, but it goes to the people who are implementing the facts. Now we are emphasizing how humans do it, and we are emphasizing that we need to follow these in general to have general intelligence. And it has already been mentioned by, for example, Newell and Simon in their acknowledged paper about strong methods.
Well, it is not only a methodological question, also a philosophical question. Mm-hmm. Because in philosophy, history of philosophy, empiricists would believe that we get those models through experience. And the naturalists would believe that we already have those models in mind, innately or hardwired in our mind. So I need to know your position. Is acquired or innately hardwired, those models? Where do they come from?
That's a good question, but I have to admit it's philosophical and debatable. I don't have enough time to answer it, really. That's a basic question, and of course he knows. So my position would say that, for example, Gerd Gigerenzer would say that everything is a toolbox. You just put it there and collect it when it's needed. When you ask it, where did these things from, then you have a Gigerenzer's answer. That's one example. Another example would be different, of course. That's debatable.
Are there any other questions? Comments? Remarks? If not, then I would just perhaps ask one question. What is relatively interesting in this experiment with the continuation of the letters is that to a certain extent, if you just look at that, I think it's relatively surprising, this outcome. That some subjects just continue with the alphabet, so they invent new symbols, for example, with E, F, G, H. Other ones skip the CA part and continue with D, A, D, B, D, C, D, D. Other ones do it correctly, what is intended, C, A, C, B, C, 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 D, and then you can cluster these things in a certain sense. So, and I come a little bit back to this question concerning how to implement this. So, would that be a possible strategy then to say, okay, we have to explore this empirically, what humans do, and then we can probably somehow at least get an idea what the background knowledge is in order and the strategy in order to apply of the possible solution space in a certain sense. And then the task is, well, give this background knowledge to a system. So for example, the system gets the information that there are not only A, B's and C's and D's, but there's also something like E, F, G, H, for example, in a sequence, and they are somehow ordered. And you can compose certain pairs together. And it's just about figuring out what is the necessary background knowledge in order to get a system that puts out different things. So would that be a strategy for, building the computational model? That's the question.
I would say yes.
Mm-hmm.
because it depends on the background knowledge. It depends on the experience, the previous experience. If this agent or this person has encountered such situations before, if the agent is lazy enough not to continue from BD to find CA or DA, but just make something analogous by thinking about starting a new sequence like E, F, G, H, or even using other things by abstracting, not to English alphabet, but to boxes, squares, triangles, something like that. And then they will discover the problem and continue reconstructing the idea, maybe later.
You said, and maybe that is well known, that you believe that the CACB is the correct continuation, and you are surprised sort of about these answers. So I'm not surprised about these answers, because it seems that for me all of them are plausible, and the C's is actually the least plausible, right? Okay. But did you just make it up that CA is the correct continuation, or is that generally agreed on that this is the best?
No, with all these continuation things, as long as they are not in an intelligence, that's where it's usually considered to be a strongly psychologically preferred solution for this. Because in every sequence you have usually infinitely many recursive functions and compute to every possible sequence whatsoever.
I know that.
In this sense, the idea was that it's highly underspecified.
Yes.
And that there are many possibilities.
Yes, right. Yes.
But the very idea is that it's A is 0, B is 1, C is 2, and D is 3, and then you get just something like, so that was it's a number system. So it's 0, 1, 2, 3, 1, 1, 0, 1, 1, 1, 2, 1, 3, 2, 1, 2, 0, 2, 1, 2, 3, 3, 2, 3, 4, and then 4, 0, 4, 1, 4, 2, 4, 3.
No, well, either A is 0 or A is 1, and in either case it doesn't work, right?
No. 0, 1, 2, 3, 1, 0, 1, 1, 1, 2, 1, 3.
Yeah, okay, now I see. Yeah, okay.
No, probably I did it wrongly now, but it works, right?
Okay.
Yeah, but also for people who doesn't know that this might represent a sequential number, this might be something like, why do we skip here? We don't have AA, AP, so they skip instead of...
That would have been my thought, right?
Yeah.
So before A is just empty, yeah? You have empty and you skip.
And that people did that, right?
Okay.
That have been actually reported in the experiment as a nil symbol.
Yeah, right. And they were talking about, they do this, and I think we have not enough time, but we can later talk about that, because the interesting thing is how they explain what they do. And they refer to an analogy to another case, which is seemingly similar. They report to some graphical representation, like this pyramid construction. And this was extremely interesting, what type of background knowledge was used in order to construct these solutions. We need to go on. Thank you very much.